All right, in this video, we're going to work through the following example. It says solve the triangle. So first thing to do is let's sketch out this triangle. So just draw the standard triangle that we've been drawing with angles A, B, and C, and then label the angles in the correct way with side A across from angle A, side B across from angle B, and side C across from angle C. And then we are given that A is 29 degrees. We are given that A equals 1 and C equals 4. Okay, so you can see we are given two sides, and the angle we're given is not in between the two sides, right? That would be angle B in between these two sides. So we are in the side angle case, okay? And so what we're going to do is solve for the sine of one of these angles, one of the missing angles, either angle B or angle C. And I am going to pick C in this case to solve for. And so using the law of sines, I would know that the sine of angle C over side C would be equal to, and then now I'm going to have to use this angle A, right? Because it's the only angle side pair that I know, right? I know that angle A is 29 degrees, and I also know that the side A is equal to 1, right? So I get sine angle A over A. All right. So, and then now I know what these values are. So sine of angle C is the unknown here. And then I know that side C is 4. I know sine or angle A is 29 degrees. And I know that side A is 1. Okay. All right. And so then if I cross multiply, I get 1 times sine C, which is sine C, right? And then 4 times sine 29. Like so. All right, and so now I want to find out the angle C. So what I would do is use the inverse sine. All right, to figure out what angle C would be. All right, so go over to your calculator and make sure that you are in degrees in this problem, right? And so I want to enter inverse sine of 4 times 29 degrees. So for Desmos, I have to enter that as arc sine of 4 times sine of 29 degrees. And you can see that I get undefined when I go to do that. What that means, right, is that there are no triangles here. So looking at our procedure for doing the law of sines, right, this is what we did. We used the law of sines to solve for the sine of the unknown angle that is opposite one of the given sides, and then we took the inverse sine of that, and we're right here. If the calculator gives you an error in the step, the problem is over, right? There are no possible triangles with this configuration, right? And so all we can say here is that there are 0 triangles with this, and that's it. So that's the end of the problem.